Okay, so the last segment today is going to be our thinking section. We are going to work through this together to kind of see. So, first question states that 1/3 of Canadians regularly read the news online. Read news online. And also 12% rarely read it. Okay, so you've got three options: regularly read, rarely, or never read. So the question, the first question would be, how many people read online? So that's considering both regularly reading and rarely reading. So why this is a thinking question is the following, right? We've got our fraction here. We're trying to get a bigger number. How many people read online? Okay, so regularly read or rarely read, but we're faced with a percentage here. So the first thing that we need to do is break down that percentage. We know that 12% is the same as saying 12 over 100, which is the same as saying 6 over 50, which is the same as saying 3 over 25, right? If I divide all by half, I get 3 over 25. Can't reduce this any further, so I now have the fraction I'm going to be working with. So I'm going to be working with 1/3 plus 3/25. So at this point, I need to take a step back and say, okay, what numbers go into both? Well, let's count up by 25. 25, 3 doesn't go into it. 50, 3 doesn't go into it. 75, 3 does go into. So I'm going to be working with 75 here. So 25 to get to 75, I multiply it by 3. So I'm going to do the same for the top. 3 times 3 is 9. 3 to get to 75, I'm going to multiply by 25. So I got to do the same to the top. I got to multiply 1 by 25. So I've got 25 and 9, which equals 34 over 75. Can I reduce these any further? I can't, unfortunately. But now here's the second part of the thinking question. The second part of the thinking question asks, how many don't read at all? So in order to figure this out, what I've got to look at is this final fraction. And I've got to take the denominator and subtract the numerator from it. So I'm going to say 75 minus 34 is 41. So 41 out of 75, 41 75ths do not read it, and 34 75ths do read it. So two parts that made this a thinking question. One, you will kind of see these ones next year where you're given a fraction and a percentage, and you have to figure out how to do the addition together. And the second part is working backwards once you have a fraction, seeing how you can get the other one. Okay, so that's thinking question number 1. Our second thinking question is the following. So Kevin bought 3 pizzas. Okay, well, it's not centered at all. Kevin bought 3 pizzas. They ate 1 and 5/12 of the pizza on Monday, and they ate 3/4 of the pizza on Tuesday. And this 3/4 of the pizza is the total pizza, okay? So it's not what was left, that kind of situation. How much has been eaten? And then how much is left, okay? So let's do the eaten part first. So we will take a look at this. 12 times 1 is, our expression is 1 and 5/12 plus 3/4. 12 times 1 is 12, plus 5 is 17 over 12, plus 3/4. Find the common denominator. 12, yep, 12 is good. So 17 stays on top. 4 times 3 is 12. 3 times 3 is 9. So I'm given 26 twelfths. Let's make that into a whole number. So 26 mixed number, 12, 24, so that's 2. And I've got 2 twelfths remaining, but we know that that can be simplified into 2 and 1/6. So 2 and 1/6 is how much has been eaten. If I want to work backwards, and I've got 3 pizzas total, let's say the pizzas are out of each of them is a sixth, right? Because here we're looking at this, we say, okay, 1/6 is eaten. How many are remaining? Well, just by looking at the simple math, we know that 5/6 is left. 5/6 of the pizza is left. Okay, so again, we're using our reasoning skills to look and say, there's 3 pizzas eaten, and 1/6 is left, 2 and 1/6 is left. If I add 5 to that, it becomes a 6/6, which is, as we know, a whole. So that would make the whole number 3. The last one I'm going to ask you guys to do on your own. It's going to be a little bit of a longer step, but I want to see that you guys can kind of do it. So Rishi, no, this one doesn't work, so I'm not going to use this anymore. Let's do this one. So Rishi ran for half an hour on Monday. He ran for 5/6 on Wednesday. He ran for 2/3 on Friday. And these are all hours. Okay. And he ran for 3/4 on Saturday. So question 1 is how long did he run for? And question 2 is, which half of the week did he run longer? So did he run longer on Monday and Wednesday or Friday and Saturday? So let's take a look. So take a pause and come back when you've completed it and we'll solve it together. Okay, so you're back, which means that you've completed it. So the first thing we need to do is figure out this, how long did he run for? So we've got 4 fractions. We could take them at, if you wanted to get a head start on the second one, you could do the first 2 and the second 2 and then add those up. Totally up to you. I'm going to do all 4 at the same time just so I can show you how to kind of look at lowest common denominator together. So we've got 2, 6, 3, and 4. So I'm going to count it by 6. So 6. 2 goes into 6. Yep. 3 goes into 6. Yep. 4 does not. 12. 6 goes into 12. Yes. 2 goes into 12. 3 goes into 12. 4 goes into 12. So my next line will be, will be all out of 12. 2 to 12 is times 6. 1 times 6 is 6. 6 to 12 is times 2. 5 times 2 is 10. 3 to 12 is 4. 4 times 2 is 8. Oops. 4 to 12 is times 3. 3 times 3 is 9. So we'll add these up. 6 plus 10 is 16. 16 plus 8 is 24. 24 plus 9 is 33. So we've got 33 over 12. And we're going to turn that into 12, 24. So we're 2. And there's 9 over 12 left, but we know that that can be reduced to divide both by 3, and we get 3/4. So he ran for a total of 2 3/4 of an hour. So that answers the first question. The second question is, which did he run for longer, Monday and Wednesday or Saturday and Friday and Saturday? So for that, we're going to do Monday and Wednesday first. Okay, so Monday and Wednesday, we've got 1/2 plus 5/6. In this case, it's pretty simple because we know that 2 can go into 6. So one of our fractions is going to stay the same. How do we get from 2 to 6? We multiply by 3, so we multiply this by 3. Our answer will be 6, 3, it's 8/6, or what we know as 1. Did I do something wrong here? Did I? No. 1 and, what is it? 2/6. So we know that that's going to be 1 1/3. On what do we got? Friday and Saturday, we've got, what do we got? 2/3 plus 3/4. So this is going to be at a 12, and this is going to be at a 12. At this point, I'm going to run into an issue. At this point, I'm going to run into an issue because it's going to be harder to compare 6th and 12ths. So what I'm going to do actually is I'm going to go back to this original one. I'm going to turn both of these into 12ths as well. So I'm going to go and I'm going to turn this into 12 so that I have common denominators all the way through, right? Which is kind of what we had here. So this is going to be 6 and this is going to be 10. So we're going to have this then become 16/12. Okay, it's going to work out to the exact same way. We're going to have 4/12, which will be reduced to 1/3 or 1/4, sorry. No, 1/3. So let's go back to here. So how do we get from 3 to 12? We multiply by 4. 4 times 2 is 8. 4 times 3 is 12. 3 times 3 is 9. 9 and 8 is 17/12. Well, we already know just by looking at this line which day they ran a little bit more. They ran 17/12 on this day and they ran 16/12 on this day. So on Friday and Saturday, they actually Rishi ran more than he did on the Monday and the Wednesday. So the thinking portion here is being able to say, I'm not going to be able to compare. It's going to be harder to compare when I don't have the same denominator. So changing it to the same denominator at this level actually makes it more clear. So there is going to be a slight exit card, which I'd like you to complete. And that is the math lesson for today. If you have any questions, please feel free to reach out to me at any point. Talk to you later. Bye.